Hello everyone, welcome to this video series on database management system. So in this video we are going to discuss one of the very important topics in DBMS, which is asset properties. Okay, right. Now we know that multiple transactions can execute concurrently or simultaneously, right? I told you there is this thing called interleaving of actions in transactions. Okay, so whenever the transactions are executing concurrently or simultaneously, the DBMS should ensure 4 properties of transaction. Okay, why these things need to be ensured is, if these things are not there, then there will be different problems which we will see in another video in the future. Okay, but for now we will see what are these 4 properties. So acid refers to atomicity, consistency, isolation and durability. Okay, atomicity, consistency, isolation and durability. So let's start with atomicity. So atomicity is very simple. For example, a transaction has 4 operations. Let's say read write, 4 operations. Now the transaction has performed first 2 operations and then it has paused. Okay, the transaction is suspended for some time, and meanwhile, due to some system failure, the transaction has aborted. Okay, transaction has aborted. So what about these 2 operations? They are not performed. Okay, only two actions were performed and the other 2 were left out. So it should not be like that. That is called atomicity. Atomicity means either 4 actions should be performed or zero operations should be performed, either all or none. Okay, so partial execution of transactions should not be done, right? It should be avoided. Okay, so this is the first property, atomicity. Okay, now let's see this example. You can see there are 2 transactions, transaction 1, transaction 2. Okay, and you can what is the meaning of this is read operation on object A. Okay, and this is write operation on object A. Similarly, read on B, write on B. Similarly, here also transaction 2 is reading A, writing A, and then reading B, writing B. And finally, one more operation you can see here is, in both transactions at the end there is commit. Okay, commit means whatever changes are done by the transactions, they are stored in the database. Okay, whenever commit is executed, the changes done by the transactions are stored in the database. Then, for example, here a change is made, right? Write means some modification is done. What happens to this write is, it is stored temporarily in a buffer. Okay, temporarily this data is stored in a buffer. Okay, fine. Then once this commit happens, this data is stored into hard disk. Okay, right. Now if you see this, transaction 1 is performing these 2 operations, then it is moving on to transaction 2. Okay, so if you see here, transaction 2 is reading the value of A. Okay, now initially, before the transaction started execution, let's say the value of A is, for example, bank balance of A is 1000 rupees. So here what this operation will read? This operation will read 1000 rupees because initially A is 1000. Now let's say we are transferring 500 rupees from A to B. Then what will happen? 500 rupees will be deducted from A, right? So A will become 500. Now when T2 is reading A, it will get this 500. Okay, and it will perform its own actions. It will commit and go, leave the system. Then let's say here system failure has occurred. T1 is not complete yet. Okay, it has some more operations to perform. Now there is a system failure and the transaction has aborted. Transaction has aborted. Aborted means these actions will be cancelled. Okay, now this is a problem, right? That means according to this transaction, A's balance is 1000, but here T2 has read 500, which is not correct. It should be 1000, right? But it is 500. It has done some operations, it has committed, and it has saved the data. So the data in the database has become inconsistent. So this is the problem of, or you can say the property of atomicity. Means after some operations are done, you can't cancel here. Okay, you should perform all the operations, or you should not perform any operation. That is called atomicity. You should not perform only some operations and stop. Okay, right. And second property is consistency. So consistency means the data in the database at all times should be correct and complete. The data in the database everywhere, I mean before the transaction and after the transaction, should be correct and complete. So this is called consistency. So here you can see an example. What we are doing is, initially in A's account the balance is 1000, in B's account also the balance is 1000. So 1000 plus 1000 initially is 2000, right? So this is before performing any transaction. Now here A is transferring rupees 500 to B. That means what happens to this? This becomes 500, okay, and this becomes 1500. Okay, so this is after transaction. So after transaction also, if you add them, 1500 plus 500, this becomes again 2000. So in this way you can say that the operation is consistent. So this is called consistency. Okay, so whatever data is there in the database before transaction and after transaction, it should be correct and complete. And third one is isolation. Okay, so if one transaction is doing something, it should not affect another transaction. Okay, that is called isolation. Okay, I am repeating again. If one transaction is doing some operations, these operations should not affect the operations of another transaction. They should be isolated. Okay, they should not be dependent, they should be independent, right? That is called isolation. Fine. And here you can see transaction 1 and transaction 2. I can say that transaction 1 is perfectly isolated from transaction 2 because it is doing some operations. After doing the operations, it is committing. Okay, its job is done. Okay, then transaction 2 is starting doing its operations, and then it is committing. It is done. Fine. So this is called serial schedule. Why I am saying it is a serial schedule? Because T1 is executing first, then T2 is executing next. So there is no chance of any collision between T1 and T2, right? Or if you perform T2 first, T1 next, that is also fine, right? Okay. And last one, fourth one is durability. So durability means whenever transactions are making some changes, those changes should be permanent in the database or in the secondary storage, that is hard disk. Okay, you are writing some data, the transaction has made some changes, those changes are committed. That means the committed changes must be stored on hard disk permanently. They should not be lost because of maybe system failures like this. That is called durability, right? So these are the 4 asset properties: atomicity, consistency, isolation, and durability. Now who is going to take care of each of these 4 properties? So atomicity is the responsibility of transaction manager. and consistency is the responsibility of the programmer. Isolation is the responsibility of concurrency control manager, and durability is the responsibility of recovery manager. Okay, so if you see this one, first one, third one, and fourth one, these are all parts of DBMS. Okay, they are all part of DBMS. Only this second one, consistency, the programmer while writing the code should take care of this consistency property. Okay, fine. And to end this topic, asset properties, we are going to see in which cases the transactions are treated as incomplete. When can you say the transactions are incomplete, or when do they stop in the middle and they abort? Okay, so you can say a transaction is incomplete when it is aborted or terminated because of some anomaly. Okay, like for example, the internet is not working. Okay, when the internet is not working, the transaction will stop immediately. Okay, it is aborted or terminated. And second case is there is a system crash. For example, there is a power failure or power shortage. And third one is the transaction is aborting because due to some unexpected event. So examples are dirty read or some error which is related to hard disk access. Okay, maybe the disk has failed, then data cannot be retrieved from the disk. That is called disk access error. Okay, so in case of these incomplete transactions, what the database DBMS should do to ensure this atomicity, right? We discussed already atomicity. After performing some transactions, if the transaction is aborting, then you should undo all the actions. That is called undo. Okay, right? So that's it. This is about the asset properties, atomicity, consistency, isolation, and durability. Okay, so please like the video, share it with your friends, and subscribe to my channel for latest notifications. And if you have any doubts in this video or any comments in this video, you can comment below the video. Thank you.